should be able to write the thetas directly. So what is the theta for this first one, first summation? N to the 5, right? Because we have I to the 4, so this is n to the power 5. Plus, we have 2 here, you can take the 2 out if you want, it's a constant. So we have sigma I equals 0 to n minus 1 I squared. So that is n cubed. And then you have sigma I equals 0 to n minus 1, 1. That is, if it's 1, it is n. If it's only I, it is n squared. Okay? So you have theta of n. So we have n to the 5, n cubed, and n. So that should be equal to n to the power 5, because that's the most dominating of the 3. Right? Okay? Clear? Any question? So taken all the formula? Okay. So let's do the last one. So I'm working out, so I may ask all these things in the exam or quiz. So you have to make sure you practice them. So the last one reads like this. I equals 0 to n minus 1, and then sigma double summation. J equals 0 to I minus 1, I plus j. Right? So it looks complicated, but I have done all the steps, intermediate steps there. So let's do it again. How do you simplify this? For the time being, forget about the outer summation. Just let's work on the inner summation, because we have to start with inner summation. Okay? So you can even pull it out separately and do that. So the inner summation is sigma j equals 0 to I minus 1 I plus j. So what we can do, when we have situations like this here, we took the summation inside, right? So same thing can be done there. Okay? Clear? So now tell me this thing. I can write one step, which is the intermediate step. J equals 0 to I minus 1 I plus sigma j equals 0 to I minus 1 j. So now tell me, is I a variable in the summation or a constant in this thing? Here in this. So is I a variable or a constant? When you say something is a variable,
Varied.
then its value varies, right? The value of I varies here or not?
Yes.
In this. Where? How does it vary? It's a constant, right? You see here j equals 0 to I minus 1. Instead of our n that we used to have so far, we have I minus 1. That's a constant. I is a constant there in the upper limit. And then you have an I here, but this I is like a constant because this summation, right? The only variable in this summation is what? J, because it's only J's value that goes from 0 to I minus 1, right? So I is a constant in the summation. Only J's value goes from 0 to I minus 1. Similarly, here again, I is first of all not inside there, but here it is from the upper limit, but it's again a constant. So only J varies here. Huh? Take out the I outside, because it's a constant. That's what you're about to say? It's at the end? Yeah, so we'll do that. So we have to tap a little bit here. Our n is not appearing yet because we are just on the inner limit now, right? The inner summation. So the first summation we can take the I outside, right? For the first one I can say I can be taken out. I can say j equals 0 to I minus 1, 1 because I said my I is a constant. Okay? Then plus, what about this? J goes from 0 to I minus 1 j. So let's apply the formula. if it is from 0 to, you want to write your familiar form, with 10, you can write it on the side, just to avoid making mistake. What was the formula that we know? We know, let's apply J itself so that we don't make mistake, right? J equals 0 to n J, it is what? Instead of I just use J. If J equals 0 to n J means 1 plus 2 plus up to n. That is what? N times n plus 1 over 2. So instead of n here, we have the second summation, we have what? I minus 1, right? So instead of n, apply I minus 1 for n. So that should be for n I minus 1. So that should be I minus 1 times, we have what? I minus 1 plus 1, right? So that should be I over 2. Okay? So now let's simplify the first summation. We have an I out, and then what is this? J equals 0 to I minus 1, 1. That's equal to what in our standard notation? If you apply J as the limit, we have 1. So what is that? We have a 1 here, what does it mean? Or which formula should apply?
n minus 1.
N minus 0 plus 1, right? Upper limit minus lower limit plus 1. Right?
Right.
So instead of n, we have again I minus 1. Right? So if J equals 0 to n, 1 means what? Upper limit is n minus lower limit is 0 plus 1. Right? That's equal to n plus 1, isn't it? Instead of n here, we have what? I minus 1. Right? So if you substitute I minus 1 here, the whole thing simplifies to I minus 1 plus 1, which is just I. Okay? So the whole thing simplifies to I. Okay? Plus we have your I times I, or I minus 1 times I over 2. So all that's left now is just simplifying this to a certain extent, and then remember we are just solving the inner summation, then we are use our outer summation. Right? So this is what I square plus I square minus I over 2. Right? This is I times I square plus, I'm just multiplying the I inside, so I square minus I over 2. So this is I square plus another I square over 2, that is what? I square plus I square over 2 is 3 halves of I square, right? I square, 1 times I square plus half times I square, right? So that is 3 halves of I square.
Wait, back up.
Huh?
You got I squared plus I squared minus I over 2. And you got
Yeah, so you have to have an I minus I over 2. What was your question?
What is the 3 I squared from?
This is I square, right?
Right.
Plus
I squared.
over 2. You want to break it up? Let me break it up one intermediate step. This I square, this is I square, right?
Right.
Plus, let's break it up. This is what? I square minus I over 2. So this is what? I square over 2 minus I over 2. I square over 2, the thing is whole divided by 2, right? I square minus I over 2. So that is I square over 2 minus the I over 2. So now we have an I square plus I square over 2. What is that? 1 plus half kind of stuff. So 1 plus half, this is a 1, this is a half, right? So 1 plus half is 3 halves, right? 3 half I square. This is 1, isn't it?
Yeah, it's
1 plus half. 1 plus half is what? 3 half. And then it's basically 1 I square plus I square or 1/2 I square, right? That is 3/2 I square. Everybody? Or you want to take LCM? You're used to that? Either way is fine. 2I square. Then minus what? I over 2, right? Is that clear there? So what is that we are left with now? That term. So now you have to plug it in for the outer limit. So we solve basically this part. Okay? So we have to say now this is I equals 0 to n minus 1, 3/2 I squared minus I over 2. So what do you have to do now? You understood up to this point? Right? So, bring the summation inside because we have everything in I now. Okay? So I is our variable now. So bring it inside. So this is sigma I equals 0 to n minus 1, 3/2 I square minus sigma I equals 0 to n minus 1, I over 2. So now it's in our familiar form. So you have 3 over 2 as a constant. So it's sigma I equals 0 to n minus 1. You have what? I square. And then you have an I. So what should be this in terms of data? Somebody from here? Second row or this second and third or fourth column or something like that. What is this? Yeah, but somebody from here should tell. It's I square, right? And Q. So somebody from this side. What is this? I 0 to n minus 1, you have an I. Half is a constant, I can take it outside. So look at that I. So this should be equal to theta of what? N square. So n cube, theta of n cube minus theta of n square. So which is the most dominating? N cube. So that should be your answer. Okay? So practice this one more time. Okay? I could ask you this.
You said there are practice problems on the website?
Yeah, practice on those on the slides and practice those on the solutions. Everything off here will also be in the question bank. Plus some more will be there, so you have to practice. Okay? Alright, so now let's move on with the next set of problems. So continuing with this basically, we are going to now look at algorithms and analyze the time complexity. Okay? So the first thing we are going to look at is an algorithm to find the maximum element in an array. You should have done this as one of your projects in 118, assignments in 118. Don't tell me you didn't do that.
On the back down?
Yeah, how do you find the maximum element in an array?
I think so.
Huh?
Don't think so.
You
We
didn't do it?
did. We did. Yes, we did.
So at least now tell me the logic. What should be a logic to find, given an array, what should be the maximum element? How would you find the maximum element in the array? So let me even write some numbers.
So the logic will be that you would set the first element to the largest and compare each element to the one that's the largest until you get to n minus 1. Then if n minus 1 is not the largest, whatever n is, that will be the largest element in the array.
Just a small correction. In between, if you come across something else which is larger than your current largest, you have to update that to your current largest. Alright, good. That's the logic. So what should you do? Like we said, so the array starts from index 0 to n minus 1. So set your temporary maximum or current estimate of your maximum to be the first element. So we'll represent the array label A. So A have to move from I equals 1 to n minus 1. You don't need to look at the first element again because you have set that to the current maximum. So what you have to do is you have to check if A of I is greater than the current maximum. If A of I is greater than the current maximum, which means what? That some other element is greater than the current estimate of your maximum. So then you have to set your maximum to be your A of I. Otherwise, you just leave it as it is. This is not a Java program. This is what's called pseudocode. Okay? You shall see this in data structures, right? Pseudocode is like writing the logic in English in a programming format, but it's not really a program that can compile. Okay? Have you seen pseudocode like this? Yeah. So the same thing is written over here. Of course, the end is not there, but that just makes it more formal. So what you do here, you go through this array, the whole array, right? Like use a for loop or while loop, whatever loop. Go over the array from I equals 1, 2, 3 up to n minus 1. Right? Remember the first class or second class I introduced a term called what? Basic operation. Right? So what is a basic operation here? What did I say that time about basic operation? The one that is the most time consuming step of your algorithm, right?
The most in a for loop?
The for loop, but within the for loop what you're doing?
Compare.
Huh?
Compare.
Comparison. Each iteration you are doing a comparison, comparing your current estimate of the maximum with that particular array element. Right? And equal to, you may think that is also an operation, yes, but it's not a basic operation. Why?
Doesn't take very long.
No, it may take the same time as comparison, but let's look at that a little later. But it is not executed all the time. Only if A of I is greater than the maximum, you are assigning this, right? So there's no guarantee that you are doing this assignment operation every iteration. But you're always doing this comparison every iteration. Right? Only if A of I is greater than the maximum, you're doing assignment. So you're doing this comparison all the time. Okay? Clear? Any question up to this point? Now, we also saw previously, when you look at time complexity, like how many times you're doing this basic operation, I said what? 3 scenarios. Best case, worst case, and average case, right? What is the best case here?
Once. Well,
Can you do something in one iteration? Can you find the maximum element in one iteration? No, right? You have to go through the entire array, right, before you decide what's the maximum. Isn't it? Yes or no? Which means, what's the worst case? Still you have to go through the entire array, right? So the best case, worst case may be the same thing like this example. It need not be always 2 distinct cases, the best case and worst case. In this example, the best case is the same as worst case, which means what? Which is what? Going through the entire array. Clear? Even the average case. In our average also you have to go through the entire array. Next example we'll see where we have different average case. Okay? So in this example, all the 3, best, worst and average, everything is the same thing, which is actually the worst case. It means we have to go through the entire array. There's no other choice. Okay? Clear? Any question? Not right now, that is the answer all the time. Okay, so now let's count the number of, how many times you are doing that? How many times you are doing a comparison? Is it the n or I want the exact answer? You are starting from I equals 1, right?
Right.
You are doing from I equals 1, 2 up to n minus 1. So you see how my summation is applicable now? Well, this is my iteration index. I equals 1 to n minus 1. What I'm doing in each iteration? One comparison, right? So, my number of comparisons, like worst case, you can call worst case or average, in this particular thing is the same thing, right? Comparisons is equal to sigma I equals 1 to n minus 1, 1. In each iteration, each value of this index I, how many times I'm doing the basic operation? Once. One comparison. Right? So that's how we have to put it. Is that clear? How I got this? So now what formula you should apply and tell me the answer. Someone again from the middle. Upper limit.
n minus 0 plus 1.
N minus 0 plus 1. And is that right? No. N minus 1 is upper limit, right? Minus 1 is the lower limit plus 1. So it's n minus 2 plus 1. So it's n minus 1. Which is theta of n. It makes sense from the array too, right? We're going through the array how many times? 1, 2, 3 up to n minus 1. We're comparing it to the last element.
Oh,
Okay? Clear? Okay. Now let's look at the second algorithm. That's actually your project also, first project. And we saw this in the first class itself, the element uniqueness problem, which means I want to find, given an array, whether the array has unique elements or not. How do you do that? What's your logic? Given an array, we want to find whether the elements in it are unique or not. What I mean by that? Tell me here, this array, sorry I'm moving back and forth.
That's fine.
Okay. So in this array, tell me whether this array has unique elements or not, which means are every element distinct, different? Huh? They are all integers, but are all different integers?
Yeah.
They are all. And I wrote.
Oh, no, okay, no.
You have 10 here, right? 10 here and there. Yes or no?
No.
Yes. So this array does not have unique elements, right? So if I have 0, does it have unique elements now? Yes. That's what I want to find. Given an array, I want to find whether it has unique elements or not. Okay? We saw that in the first class. So tell me the logic. I told you that time. What you should do.
It's pretty much the same except for
Louder.
Huh?
Louder. You said something, right? What's the logic?
I mean, I was saying it's pretty much the same except for if you run into one that is, it's not going to be a max, it's just going to be equal. If it's equal, then it's going to be false. If you run through the whole array and you don't have anything that's alike, then you're going to return true. That there's something that's different.
Is that sufficient to do just once? Like if I take the first element, 10, right? I take the first element, 10, and let's assign that to some temporary variable, some temp or something is 10, and what you're telling is just compare with each of them here. If it's not there, can you say the array has unique elements?
You have to do it for every element.
You have to do it for everything. Just one pass may not be sufficient. What if you have a 2 and 2 here? Your test will compare 5 with 10, 5 with 10 with 15, 10 with 2, 10 with 3, and so on. They will not be equal to 10, but something else is repeated, right? So what you have to do is do this several times. How many times? Take this 10 and go over the entire array, right? And then what you have to do?
Do it for 5.
Take over the 5. Remember again, if you encounter a 10 like here, you can right away stop and say the array does not have unique elements, right? Because you want here in the algorithm just an yes or no answer. So if a 10 is repeated somewhere else, you can just stop there and say it does not have a written false, and which means it does not have unique elements. Let's say it's not there. So then we have to pick our 5 and walk over the rest of the array with 5. So compare 5 with 15, 5 with 2, 5 with 3, and 2 and so on. If you again hit somewhere another 5, you can return false right there. If you still could not find a repeated element,